Yeah, number 8 is about torque also, yeah. A traditional pair of scale use sliding meshes of 10 gram and 100 gram to archive a balance. A diagram of the range figure 4.23 yang ini, this one ya. Okay. The bar itself to support it with its center of gravity at pivot ya. First one is calculate the value of M attached at X. Step 1 advantage method measuring mass. Determine upward force on the pivot on the bar. Oke, kita cari dulu mass dulu deh yang pertama ya. This one. I will use view biar ada kotak-kotak. Nah ini. Oke, kalau sergambar ya, if I this is pivot, ya, di titik ini, and then we have 100 gram and 10 gram. So in 100 and on the 10 gram they have force, yeah, they have force, yeah. This is mg. Let's say this is 0.1 Newton. Yeah, when gravitational acceleration, let's say 10. Yeah. Oh, hmm. Kok miring-miring. 10 meter second minus 2. Yeah. This is 0.1 Newton. And then here is 0.01 Newton. Yeah. So we use torque, yeah, with all mass ini ya, kita cari mass ini ya. This is also mg gitu. So on A this mg, ya, distance is 20 centimeter, gitu. It will be equals to if we use still in gram, yeah, 100 gram times distance is 30, ya. Kok begini, 30 plus the second one is 10 gram, ya, times distance perpendicular is 45. Oke, Bapak kelewat ini ya, G-nya ya. Kita nggak pakai G, misalkan ini sebenarnya udah times G ya, times G. Gini. Okay. So ini 20 M equals to 3000 ya, plus 450 ya. So M equals to 3450 divided by 20. So M equals to 345 bagi 2 ya. 345 bagi 2. 172,5. This is 1 point 170. 172 yang 0.5. 172.5 in gram, ya. Why in gram? Because this is in gram also, ya, in gram, ya. Or we only okay, that's it. This is for question A. Yeah. And then what about question B? Question B is state one advantage of this method of measuring mass. Apa ya? Ya ini apa namanya? Kita sebut tepat ya, tepat artinya exact measure ya, sebutlah exact measure, atau kalian bisa nanti bikin sendiri kalimatnya bahwa ini ya, and then simple also ya. Kalau boleh deh Bapak tulis ya. Kok ini ya, ini simple ya, and then kita sebut equilibrium, or exact ya, pasti nilainya exact, dan seterusnya. Bisa kalian kira-kira apa jawaban yang tepat ya. Okay, then see question. See question is determine the upward force of the pivot on the bar. Okay. Now this is, I think, about Newton first law. Yeah, about total force equals to zero. Yeah, we have on the pivot, we have force here. Yeah, let's say F. F means total force vertical downward. Yeah, the first one is mg. This one. Yeah, we have mg. Yeah, this is in kilogram is 0.1725. Yeah, and then times 10. Yeah, this is equals to 1.725 Newton. Yeah, so F on the pivot 1.725 plus this one 0.1, yeah, on the 100 grams, yeah, 0.1, and then uh, the third one is 0.01, yeah, 0.01. So force total on the pivot is 1.8 35, yeah, Newton. Yeah, that's it. Okay. Okay ya. If you have any question, please ask me. Kalau ada yang bertanyakan atau ada yang aneh-aneh, silakan bertanya ya. Kita lanjut question 9 ya. Coba kita lanjut question 9. Question 9. Okay. Figure 4.24 show a beam for force acting on it. For each force, calculate the moment of the force about P. Okay, about P. P is in here ya. This is pivot. Kita sebut ini adalah pivot. Then we have force 1, force 2, and force 3. But for 3, we need to use the perpendicular one. Yeah. This is F3 sine ya. F3 sine 30. Let's say this is equals to F3 is 10. Sine 30 is a half. Yeah, so same thing with 5 Newton. Yeah. Ever already in right angle. Yeah. So in question A, yeah. For each force, calculate moment of the force about point P. Yeah. Torque in P equals 2. We have about clockwise and anti-clockwise. Yeah. We see on the this one, when the clockwise is positive and anti-clockwise is negative. We can check whether of With mana yang kemarin ya, clockwise anti clockwise. uh, oh, this one, for any object equilibrium the sum of clockwise moment. Oh, ini in the equilibrium ya, in the equilibrium when the torque on the clockwise is same thing with anti-clockwise torque ya, moment. Okay, we decide on when the clockwise is positive and when the anti-clockwise is negative. Uh, Seperti itu aja misalkan ya. Okay, torque P, yeah, this is the first one, F1, we have F1 but distance is 0, ya. Bisa kita sebut gini, F1, ya, times 0, ya. Why? Because distance is 0. On the P, ya, dia bekerja on the P, so distance is 0. Plus, this F2 is clockwise, ya. F2 and distance of F2 D2, yeah, 25, but this is in centimeter. We can change in meter, yeah, in 0.25. And then F3 also clockwise, F3, yeah, and then the distance is uh, from the pivot P to F3 is 25 plus 25, yeah, 50, in meter 0.5. Then on the F4, yeah, F4 is negative, yeah. This is anti-clockwise, yeah, anti-clockwise, negative. This is clockwise, positive. This is also clockwise, positive. So F4, yeah, times with total distance from P to F4 is 50 plus 50, 100 ya. In meter equals to 1. Ya. Oke. Okay. Now we apa namanya? Kita masukkan nilainya ya. Ini 0 plus F2 is 10 ya, times 0.25 ya. F3 is F3 sign ya. This is 5. Oh sorry, this is F sign.
Itu nih harus line-nya harus di-convert ke meter semua.
Yes, correct. Because itu nanti akhirnya Newton meter. Ya, yeah, in SI unit. Okay. Then this is 5 times 0.5. Yeah. Then minus 4. F4 is 5 times 1. Yeah. This is 0. This is 2.5 plus 2.5 again minus 5. Tuh, 0 jadinya. 0 Newton meter. Ya, yeah, that's it. Okay, this is for question A ya. Yeah, repeat again about unit. Unit you have to change into SI unit ya, MKS, meter kilogram second. When the force is in Newton, length is in meter, yeah. Mass in kilogram. Yeah. Oke, coba kita lihat yang B, state whether each moment is clockwise or anti-clockwise. Each moment, ya itu udah terlihat ya, kalau F1 is clockwise, F2, F1 is not clockwise, not anti-clockwise, because the pivot is in P. F2 is clockwise, F3 sign clockwise, and then F4 is anti-clockwise. Yeah. Then state whether is not moment on the force is balance. Yes, ini balance ya, karena total apa namanya, total moment equals to 0 ya. Jadi on the C, this is balance ya. Why? Because total uh, total torque equals to zero. Ternyata kita dapat total torque ya on the point P equals to zero. Nah,
Uh,
yes,
ber, ber uh, berarti dia nggak clockwise atau anti clockwise kan karena nol.
yes, enggak. Dia jadi dia diem. Nah, diem. Oke. Okay. Oke, silakan kalau mau ditulis ya. Bapak tunggu sekitar 5 menit. Atau mau ambil minum or something. Ya. Oke ya, I think enough. Ya, nggak sampai 5 menit. Maybe you can ask me if you still not yet to copy this. Okay, I will. We will go to the other, maybe other ini ya. Oh, apa namanya? Other material ya. Okay, know about the torque of a couple. Figure 4.25 show force needed to turn a car steering wheel. Yeah, the force cast balance up down 15 newton up and 15 newton down. Yeah. So the wheel will not move up, down or sideways. Yeah. However, wheel is not equilibrium. The pair of force cause in it to rotate. Ini menyebabkan dia berotasi karena ada torque itu ya. Uh, with radius 0.20 stream radius. um, the pair force like V2 4 to 5 snow and couple. Yeah, a couple has turning effect, but doesn't cause an object and accelerate to form a couple. Two force must be ini two forces must be equal in magnitude, parallel. Yeah, this is parallel. Yeah, different side, but parallel. Separated by distance d. D is 0.20. Yeah. So torque of the couple 15 times 0.20, also 15 times 0, 6.0 Newton meter, yeah. And then this is clockwise, yeah, clockwise. So the rotate in a clockwise, yeah. Torque of couple, one of the force per times perpendicular distance between the forces, yeah. Yeah, torque or moment, yeah, same thing, yeah. This is force times distance, yeah. Force times distance. The force is the force is 15 Newton and the distance is 0.2. Yeah. This is also 15 Newton. The distance is 0.20. Okay. Uh, See this. Yeah. Also, this is this is question here. The driving wheel car traveling at a constant velocity torque 173 Newton meter applied to by the axis driver car figure 4.26. The radius of the tire is 0.18 meter. Calculate driving force yang provided to wheel. Oke, ini kalau kita lihat driving force same thing with frictional force on the tire ya. Uh, Kalau kita lihat ini frictional force maybe ke sini ya. Uh, hmm, F. Yeah. So in the distance 0.18 we can get torque equals to force times D. Yeah. Uh, the torque is 137, yeah, equals to force, driving force, times D is 0.18. So driving force or force equals to 137 divided by 0.18. Ya, kita lihat 137 dibagi 0.18. Ya. 761, yeah, 0.1. Yeah, this is about 761 Newton. Yeah, that's it. Okay, so try to continue in the next page or in the next. Uh, this is apa namanya ya syarat ya. Force object in equilibrium to condition. The condition that the object in equilibrium is two. Nah, ini penting sekali ya. Kita sebut bahwa object in equilibrium when they have two condition ya. The resultant force is zero. Ya. Resultant force ya acting on the object is zero. And then resultant moment also in zero ya. Ini kita sebut equilibrium ya when ya equilibrium when total force equals to zero and also total moments or torque equals to zero ya, this one. This is apa namanya syarat ya, must be, condition must be on the object when the objects in equilibrium. So this total F also in X and Y. Yeah? This is total force in X equals to zero. Also total force in Y direction equals to zero. Yeah, that's it. Okay, continue. We see next. Oh, this is directly summary ya. So the chapter is done ya. Summary. Kita lihat questionnya coba ya. Sebat question ya. This book we already sent to you in stream ya. You can download it. Okay, number one, a ship pulled constant speed by two small boats A and B as on figure 4.27. The engine of the ship doesn't produce any force. Wow. Okay, the tension in each couple A and B and the ship is 4,000 Newton. Okay. Draw the free body diagram showing the three horizontal forces on the ship. Okay. Yeah. Draw the vector diagram scale showing the three forces. Use diagram to find the value of drag force on the ship. Three free blood. Yeah. We have this the first one is force A. Yeah, this is about 4,000 Newton, and also for B, FB. Yeah, this is also same. FB is 4,000 Newton. The tension is cable A and B. Click here, yeah. So 40 Newton, 400 Newton. A ship pull constant speed. Oh, this is constant speed. Yeah, by too small boat. The engine of ship does not produce. Engine of the ship, yeah, not produce any force. Okay. So when we draw free body, but three horizontal forces. Maybe the other force is about uh, resisting force ya. Nah, sebutlah ini adalah R, resisting force, RF. Uh, Takutnya R itu bukan resultant force ya, resisting force. So, okay. Pertanyaannya itu aja. Oh, there is no other question here. This is free body diagram ya. Three free body diagram. Yeah, because three horizontal forces. Okay, draw a vector diagram scale showing the three force use diagram to find the value drag force on the ship. Oh, I see. This one. We need to apa namanya splitting into x and y ya. Here is 4,000 cos 40. Yeah. This is also from this. Yeah. This is 4,000 cos 40, and then on the y, yeah, they have to also, this is 400 sine 400 4,000 sine, yeah, 40, and then here also from b, yeah, 4,000 sine 40. Ah, okay, we can cancel about on the vertical, yeah. We can cancel this one, yeah. This and this, we can say this is zero, yeah. So on the vertical they don't have on the apa namanya, bukan vertical, on the different side, yeah. This they have resultant is zero. So drag force, yeah, same thing with resistant force. This is resistant force, force equals to two times of, yeah, two times of 4,000 cos 40. Ya. Nah, coba kita kalikan aja. This is something with 8,000 cos 40. 6,128. Yeah. This is about 6,128.3. Yeah, that's it about this one. Uh, okay, I will wait around 2 minutes if you want to copy this. Yeah, copy or screenshot. Yeah. Maybe the book is come about August Agustus ya. Mungkin bukunya akan nyampe Agustus, serdengar-dengar ya, Agustus, mungkin Agustus akhir ya. Tapi you already have about this ya. On the stream I already sent to you. Okay ya, I think enough. We will see next page. Number two. Coba kita lihat number two. A block mass 1.5 kilogram is rest at rest on a rough surface with inclined at 20 degree to the horizontal at zone feature 4.28. Oke, ini dalam kondisi rest ya. Oke, then rough. Berarti they have frictional force. Oke. Draw free body diagram showing three forces acting on the block. Okay. The first one is weight. Yeah. Oh, oh, weight. W. And the second one is apa kita sebut frictional force ya. R. Resisting force. And then normal contact force. And ya. Oke. Ini kurang rapi. Nah, Hmm. Then, done this one. Calculate the component of weight the arc down the slope ya. Okay, down the slope itu we can splitting into what I mentioned before ya. Ini seperti like this is x and this is y ya. So on the x we have here ya, and then on the y we have here, and uh, angle 20, yeah, same thing in here. This is 20 degree. So here we can decide this is W cos 20. And then on the down slope, yeah, W sine 20. That's it. Yeah, done. Yeah, this is weight that acts down the slope. Yeah, this one W sin 20 and W cos 20. Done. C. Use your answer to B to determine the force of friction that acts on the block. Okay, because this is on the rest, yeah. So total force equals to 0. Yeah. Uh, it means like W sine 20, yeah, minus resisting force or frictional force equals to 0. Yeah. Or R equals to W sine 20. W is 1.5. Let's say we use gravitational acceleration is 10. Yeah. W is mg. Yeah. Sine 20. This is about, wait, 1.13. Yeah, 5.13. Yeah, this is, yeah, about 1.1. 5.1 or 5.1. 5.13. Yeah, uh, Newton. Hmm. This is frictional force, yeah, because in rest, so total force W sin 20 equals to R. Yeah. Okay, then for C, then D determine the normal contact force between the block and the surface. Yeah, same thing with C. Yeah, normal contact force. Yeah, by using the rest. Yeah, they have total force equals to 0. So this is like uh, N normal contact force minus, yeah, W cos 20, yeah, equals to 0. So normal contact force equals to W cos 20. Oh, so kita langsung hitung saja. W is 15, ya, 15 cos 20, it's about 14, yeah, 14.0. This is about 14, yeah, Newton. Yeah, that's it. Okay, this number two. And yeah, if you want to copy, I'll wait this about 3 minutes. Yeah, please, if you want to copy. Yeah, okay. Right. We continue to number three. Yeah. I scroll up. Yeah. Mm, yeah. We have about 15 more minutes. Yeah. Let's try to solve this number three. A free body diagram figure 4.29 to 9. So three forces that act on the stone hanging at the rest from two string. Okay, this is rest here. Uh, from two string. Okay, this is tension 1, 1.0 Newton. This is tension in string 2, 0.5. And then weight of the stone. Yeah, calculate the horizontal component of the tension. Yeah, horizontal component. Yeah, horizontal component of the tension in each string. Based of these two components be equal in magnitude. Yeah. Yeah. Why solve these two components be equal in the magnitude? Because in this is in rest, yeah, in equilibrium. So they have same. Let's try to find it. This is on the horizontal. They have 0.58 uh, cos 30. Let's check how much is it. 0.58, 0.50. Oh, yeah. This is about 0.50 Newton. Yeah, this is for tension in string 2. Yeah, and then tension in string 2 on the horizontal. Yeah, this is something with 1.00 cos 1.0 cos 60. Yeah. Cos 60 is a half. Yeah, so a half of what? Yes, is equals to 0.50 Newton also. Okay, you can see this. Yeah, this is 0.50 Newton, and this is also 0.50 Newton. Yeah. This is in equilibrium. Yeah. So on the A, done. Yeah. And then the question why solve this component will be equal because in rest. Yeah, because in rest or in equilibrium. Yeah, because in rest or equilibrium. Equilibrium. Okay, now see question B. Calculate the vertical component of the tension in string. Okay, this uh, T, let's say langsung aja ini adalah 1.00 sin 60 ya, T2 Y ya, and then this is T, oh kok T2 TY ya, T1, sorry, this is T1 Y ya, T1 Y, and this T2 Y. Here T1 Y, this is equals to 1.0 yeah, sine 60. We check by calculator. This is same thing with sin 60. Yeah. Sin 60 is 0.87. Yeah, this is about 0.87. Newton, and T2 on the Y equals to 0.58 sine 30. Sine, sine 30 equals to a half ya. Jadi a half of 0.58. 0.58 a half 0.29 0.29 Newton. Okay, this is vertical component on the tension, uh, either tension 1 and tension 2. Yeah, okay. Done. Yeah, this is done. C. Use your answer to B to calculate weight of the stone. Yeah. So here maybe this is for B, and then here C. Yeah. Weight of stone equals to this one Tiy, and this because in the rest, yeah, so same thing, total force on the vertical up equals to total force on the vertical down, yeah. So this is same thing with 0.87 plus 0.29, yeah. Kita adding this number, yeah, plus 0.87, 1.16, 1 point, what, sorry, uh, 1.16 Newton, yeah, yeah, that's it. This for C, this is for B, and A already done, yeah. And then D, yeah, C done, yeah. Draw a vector diagram of forces on the stone. This will be triangle forces on the stone. Draw vector diagram of force on the stone. This one. Oh yeah, maybe ini, let's say this is stone, yeah. So, hmm, let's say this is stone, yeah. Uh, Stone, they have three forces, yeah, about weight, about tension two, and then tension one, yeah. Uh, so, yeah, that's it. Okay, E use diagram D calculate weight of the stone. Lah, kok diulang-ulang lagi? Ini kayaknya salah. Use your diagram. Oh, I see. This is salah guys. No no. They have. You see this? This is angle is apa namanya? 90 ya. Jadi kayak gini. Hmm, hmm. This is weight. This is tension one. This is tension two. Uh, so weight, yeah. Uh, Weight is Pythagoras, yeah, from T1 and T2, yeah. T1 is 0, 1, yeah, 1, 1.0 square, and T2 is 0.58 square. Yeah. So this is when we use calculator to find it, this is about 0.58 square plus 1, and then we root it. Yes, this is same thing with 1.16 here. This is but 1.16 Newton. So you may see this, yeah, this is same thing with on the option C, yeah, this, you see this 1.16, this is also 1.16, yeah. So this is in different approximate, ya. Di perbedaan pendekatan, ya. Kalau the first one we use about splitting into x and y uh, direction, but the second one is about Pythagorean. Yeah, yeah, that's it. This is on the y direction. Yeah. Okay, done. Yeah. Okay, please, if you want to copy this, just copy, and maybe I need you to